Hello guys, so looks like we made it to the end of the semester and it's been a busy one. We had a lot of stuff to talk about, but y'all probably noticed first thing I wanted to look at tonight is we've barely scratched the surface on one game engine, right? Uh, there's a lot going on in a game engine. It's a very time consuming thing, right? And it's not just writing code. A lot of times in software development and programming, we can separate our back end and front end, but well, we've brought that point up a couple times. Video games and simulations doing basically the same thing for an engineer, only your focus is that realism, and you're not trying to stop the engineer from making his product, but you replicate it in a virtual environment the same way. Uses a lot of the concepts we apply from game development there. But both of them, simulations for engineers and game development, y'all have noticed are very time consuming, and we've kind of barely scratched the surface. So that's where I wanted to start at this evening. I went back and forth a couple times on what a good wrap up for the course would be. Sometimes it takes teaching the course a couple times to figure out a good finale. So I was going to start by looking at some stuff in Unity. So I'm going to go ahead and share my screen here. Oh, well, I guess first off, did y'all see that announcement? When I went back and looked at it the next day, I figured out pretty quick what the bug was. And when I found it, I felt kind of silly. When we were talking about it, that the collisions weren't the thing we were looking at. So I wasn't, and then some suggestions were coming up in the chat room and stuff about what to check. So y'all know how to debug that stuff. But in class the other day, I kept putting on collision enter, but we're doing a 2D game. We have 2D colliders and 2D rigid bodies, and Unity has 2 physics engines. So we needed the 2D it wasn't working the other day in class because of the 2D one. I had a list of things to try and debugging. Y'all threw out some good suggestions. Y'all threw out suggestions in the chat room and comments that I can clearly tell you you learned what you were doing when debugging colliders before, but I wasn't thinking about the 2D one. And when I noticed that the next day, I was like, oh, that probably would have been way down my list of things to check and then took forever to do. So I guess, yeah, keep that in mind, but that wasn't the one we were looking at the other day. And I wanted to look at the other thing as well. So there's always more than one way to do something. So when we were looking at cutscenes, that showed up. I'll come back to this. So there's something there. So I'm going to start by we've spent 8 weeks, pretty much, we were here most of the time every night, right? From 6 to well after 8 every night. A couple nights we were pushing the 8:50 schedule block, and a lot of stuff to talk about, and we barely scratched the surface. We looked at putting some game engines in. If we start going through here, I'm gonna go to build settings first. We kind of looked at this little area up here. Most of our games are going to have more than one level or region, or right? If we have a big 3D world, we want to split that up into regions so we don't have to load it all at once. Or depending on the situation, actually calling those levels might make more sense, and the cutscenes to help move the story along between them. We add all those to the scene and then create that. But there's all this stuff at the bottom we haven't really looked at yet. The one you're probably going to be most interested in is this one right here. It's what we're building the game for, right? We have this test environment. We run it here in Unity. We have that run button, and it allows us to monitor everything as it's going in the inspector as it's happening. If we use the visual script, the official visual scripting tool, Unity is kind of the last major engine that doesn't have an official one. but they have an endorsed one. I think most of y'all have probably seen that, Bolt Visual Scripting. Those it's node-based low-code solution, so it compiles to the same thing as the text and gives us that advantage of that compiled version is connected to the graphics, so we can watch our data flow when we're debugging stuff. That's very useful. We didn't really have time to work into that in here, and I think a whole bunch of you all saw that in the SDEV 148 class. Has some advantages, and it matches what the standards for graphics. So all the artists in game development, that's what they're formally trained on. We looked at them a little when we were looking at materials in Blender. So it gives us some consistency on it. Unreal Engine 5's been on the news lately with all their new rendering capabilities and stuff. And they focused a little more on that as well. It definitely takes a backseat to things like the train station. If you all have seen that, that was mentioned right before class. There's really, really impressive graphics, but they did some other stuff too. And the Unreal has been focusing on that, the low code way of scripting since about 2016 or so. Because, well, theirs is entirely in C++, which makes scripting really, really hard. Got a little distracted there. Where was I? Okay. So in build settings, we looked at scenes, and we were mostly building things for PC and or PC, Mac, Linux standalones, export those. One of the book assignments was for the iOS one. We can just choose that, install the build functions. They're all ready to go for us. We just have to set it up. And then it's just a matter of actually building the game and having that final result, the final product that's not in the test environment. Like always, all the complicated stuff from the engine goes away, and all we really see is this in the final build of the game. And all that stuff just runs. So building them is essentially the same. The one you're probably going to be most concerned with in our world, I was thinking, is probably WebGL. You can see if I go to that, there's a lot more options right off the bat. We have to choose all these different targets. So WebGL is the HTML5 standards. OpenGL is sort of the standard library for 3D graphics. And they make a condensed version of it called WebGL, which is condensed and better for transmissions across the network. Hence the web part instead of the regular one. There's a lot more options. So really the only option you're going to want to choose whenever you do your game for a website release is which optimizer do you want to use on your compiler? Compilers, one of the things they do, you may not have seen this yet, it's usually, it doesn't get really get dived into until much higher level classes than we have at a community college. So probably 400 level computer science classes or software engineering classes. For those continuing on to a 4-year degree, that's going to be like one of your 400 level electives, is really digging into that. But one of the things compilers do is they optimize our code. They look for inefficiencies or things that could be improved or various combinations, and it looks for ways to optimize the code. And when we make a web release, that's really the only option. Do you want to optimize it for speed, like how fast it's running across the network, speed of the game, or size, which is essentially speed of the transmission? So that's going to make a big difference, right? And I'll give you just a second to think about it. Hopefully you realize very quickly which one's going to be which. Lots of graphics, very, very nice graphics, are going to be a lot of data with less we can get by with the frame rate being a little slower on those really nice graphics, because there's a really nice thing to showing. So if your game is probably low quality graphics, optimize for the speed of the game. And if your game is very graphics heavy, like really, really nice graphics, you probably want to optimize for the file size, because then you get better transfer rates and make sure the really good graphics show up on the other side without glitches. That's really the only option. And then at that point, then you just switch the platform and build it for a web, and it'll give you some code that you can copy and paste into a web page. Actually, it would open up as a web page, but there's no decoration on it, right? There's just a big window in the middle of a web page that the game plays in. So probably want to add a little HTML code and CSS and stuff to make that look nicer surrounding the game. Same thing, PS4, you have to buy a license. So you definitely can't build that on a free license, but you can build a free, the Xbox one, you just choose the thing and switch platform. It'll seem like Unity restarts, and then this button will say build. So you build that final standalone for whichever platform you want. That's straightforward. One of the important parts I wanted to look at. Editing features, project settings. We did come over here a few times. The thing I found I do most often here is on the input manager, and just double check the axes, what all the axes are, instead of trying to remember that. We use horizontal and vertical a lot. Like, which one is fire 2? Joystick button 1. How's it apply? I thought that was the right shift key, but it doesn't have that as the negative button. So maybe that was fire 1. Oh, the left control key is our fire button 1. And fire 2 is the left alt key. Y'all are probably familiar with that. That's the most common ones, but again, we can change those. And I find I use this the most often just to see how those are spelled when I do that input.get axis in the script, instead of trying to memorize it directly. There's a lot of things here. Some fine grained controls over the physics and player stuff. Yeah, lots and lots of stuff. We barely scratched the surface. So still lots to learn. Hopefully this class was able to get you help get you moving along good on that. A better idea of what some of the things are, a little bit more practice with the stuff. Game objects, we didn't really look at this. We ran out of time to squeeze audio in. There was the quiz for it was just go find some audio samples and download those. So we have 2 options with audio. We can create it as a game object. And you see over here in the inspector, it's things that should be look fairly familiar. Load in the audio clip. So just bring that into your assets folder and drag it over here for what's going to play. Then decide whether or not it loops. And then what you'll probably do with that is, once you have it, drag it down to make a prefab out of it, and then just instantiate that prefab anytime you want the sound effect to play, or keep a audio track looping through the background or something. But hopefully that stuff looks familiar, because we've dealt with other game objects along the way. We just create an object, say audio object, say what it's going to play, what sound file it's going to play, and the easiest way is just to create a prefab from it, and then instantiate that prefab the same way you instantiated the prefab like enemy objects in some of the games. And every time you need a sound effect or something like that. We can also do those as components. All right, guess I need one. Create an empty object. So we can also do sound as a component. Lots of filters and effects we can put on them, which is an audio source that has the same thing. And then in our script for this object, we can call get component and run through the sound. Lots of different options. Y'all can click through those. I think it's a little bit easy myself. I think it's a little bit easier just to do the prefab and then instantiate that prefab, because it makes sense with the way we usually do that in most of our games anyway, especially with like enemy objects and things. We create a prefab, and then the script on our player, or maybe the controller object, or I think our textbook like to put the control on the main camera. That script will just instantiate those as needed, and audio can be handled the same way once it's a game object. A lot of things that we barely had really had much time to look at. You can see there's still so many buttons here. We looked a little bit about navigation. It is in Unity, it is an advanced debugger. So you have to like attach the debugger, and lots of tools are there. So lots of tools to help track things down. Yeah, it's an advanced debugger. We don't have the easy, we don't have the simplified versions like most of our IDEs do, where we like click on a line number and it's going to pause when we get to that. We have to write code to control the debugger. So our debugger actually needs test cases scripted up to put in there and things. Like wait for 3 seconds and push the jump button so that we can monitor something else and have our hands doing something else while that the thing causing problems happens. So you have to actually write scripts for your debugger. Advanced debugger, but everybody's got a little bit of practice of tracking down the problems along the way. That's test cases, those things are in there. Another really useful one that I wanted to point out was we also have some analysis things to kind of see what's going on. Tell us about our usage. That's why I left that 2D one open, because then there's something I can actually run with that. So I'll open this back up and go over to that analysis, and the profiler is a good place to start. I ran this right beforehand, so you see what the output looks like here. Where's a good place to put this? Stick it down here. That'll work. How do I clear that last one? Oh, click. So profiler up here gives us, this window gives us a lifetime usage on the CPU. And down here, after the run, will give us the full frame by frame breakdown of the usage. I think this is set to the collision now, because I did get that fixed and I didn't switch it back after fixing it the last time. So we run our game, see some yellow spikes, yellow screen, that's the rendering. Mostly yellow screen. I see a little bit of blue in there, a sudden blue spike there at the end. I don't know how well the camera or the Zoom screen share was keeping up with that. I'm trying to undock that. There we go. That way I can make it bigger. And then afterwards, we get a frame by frame breakdown of what was going on in the game. So that blue, that's just kind of the internal engine running the whole time. Then we have some other stuff. Looks like some things built in. So allocating some memory for things to run. What do we have down here? Okay, click on those. Lots and lots of information. So idle for 0.18 milliseconds. Did some stuff, idle for a little bit longer. And this is the simplest case. So obviously that's going to get a lot more complicated fairly quickly. Other threads? Is there anything useful there? Nope, I was expecting to see something down there. Scripting threads. Oh. As it ran through that scene, like there wasn't much going on at all in scripts. I thought I saw some blue pop up, but it gives us, this is an invaluable tool whenever we get near the end, and if we want to look for, like, say, redundancies and things happening. So I'll try to dock it again somewhere, maybe over here. That gives it a little bit of room. So again, up here, like if things are starting to slow down, right? You get to certain points in the game and everything starts to get slow. This gives us the telemetry of our program, our CPU and RAM usage and all of that stuff. You can see the little spikes there for, looks like it's mostly rendering stuff in this case. So the green is rendering, looks like it was almost all involved rendering, and it shows us where our hardware resources are being used at least on CPU. I would have thought that would click automatically into the GPU, but I might have a configuration off somewhere. So that's another very useful tool. You might want to maybe spend a little bit of time looking at and trying to make sense of those. They're kind of a standard format. So when you see profilers in other engines, there'll be a similar issue with them. Yeah, lots and lots of things that we haven't even got to. If we go to package manager, along with stuff that has been downloaded from the asset store, there's also a lot of things that are just official parts of Unity that haven't, it's kind of like there's not room. They're like, okay, there's so much going on in this interface, we can't put everything there. So some stuff was moved back here. So even beyond the stuff, all of these buttons that we didn't get to, there's all of these packages that are officially part of this to kind of add more functionality. There's a lot to game engines. They're always there. Oh, I skipped one button I wanted to look at. Earlier in the semester, there was a question about about releasing artwork on the Unity store, as far as like a way to make extra money. And and that's really easy. What you want to do is kind of maybe set it, once you get your stuff working, make sure you set them up as prefabs. That'll work. That way they're all included there. Have our crawl text, the characters, and all the game objects. And when you're ready, under assets, probably remember using the import package a couple times, but there's also an export package. So when you can export these things. So maybe the canvas prefab, the scripts, choose all the things to export and just export it as a Unity package. I'll go over to the delete folder. That's probably a good name. And you'll see the icon there. And then and then you would put that export package for whichever objects you want or something. You probably wouldn't do it for an entire game, right? You'd bring in the artwork you want and maybe some of the assets are going here where all this is. export the package. Notice like all these characters. Export this animation along with the animator controller and the animation. Have all of this, and we can export that as character run or some relevant name, and then that is what you would put on the Unity store. And when you have a character and some animations and things that you're really happy with, you just go to that folder where you have it, export that as a package, stick that on the Unity store, and put a price tag on it, and then cash the check when they send it to you. So a really easy way to make money, especially if you're going to be if you enjoy making games, but you're going to be making those things along the way. So ones that you put together, might as well throw up there and see if you can get a few bucks off of them, and just export your assets one at a time. And if you have a whole lot to go together nicely, just set up a bunch of those export packages, wrap them up in a folder itself, and then sell it on the asset store. So yeah, we definitely ran short on time. There's an awful lot there. A lot of buttons that we kind of didn't really have time to look at. I don't know what I changed. I'll go ahead and hit save. But another thing is, well, we didn't even get all the way through Unity. And Unity is only one of many game engines. So we don't want to get pigeonholed into only knowing one thing, right? The name of this course was Advanced Simulation and Game Development. Unity doesn't show up anywhere in the name of this course. So I tried to generalize things and pointed out a couple times, like Unity has the really nice Cinemachine camera package, but most of our game engines don't. That's why we looked at the script, how to do it in scripting, and just those few little controls that would get us started there. Ran out of time to do selection structures there, but you all know how to type together a selection structure. And if the character is a certain distance from the character, don't move the camera in. If the character is less than a certain distance, don't move the camera to avoid all that jaggedness and slow things down. And I tried to generalize stuff when I could, because we don't want to get pigeonholed and only know the one engine, because better engines come out. During our course, a game engine with a very different licensing registration than Unity came out. Unity, we can download it and make your own games, but when you make money, when you're going to make money off of games, you're supposed to buy a license, get a paid for pro license, which sounds expensive, but remember, if you're making money off games, it's really good money, right? That's software developer money. And when you're making software development type salaries, you're going to want to have lots of things to write on your 1040 in tax season, lots of those itemized business expenses. So keep in mind that paying for licenses is a tax write-off if it's your business. So you definitely want a lot of those when you're in software development. So it seems expensive, but it takes a big chunk off your taxes, and software developers usually aren't in the low tax bracket. They're one of the software developers are usually in one of the painful tax brackets, right up there with getting close to the people that make all their money from capital gains. So we looked at Unity, and there's different licensing agreements. Unreal came out, and you can download it for free. You can make as many games as you want, release them. They just use a royalty agreement. So instead of ever giving them one check for that license, you owe them a percentage of any money you make with their game. So keep in mind to check for licensing agreements and make sure everything's in order before you make money with it, because there's lots of different engines. They have different pros and cons to all of them. Like everything, there's always a trade-off, right? If we want to improve something one place, we have to take away elsewhere. It's kind of like that HTML export that you're probably going to want to send most of your games to, because everybody uses the internet's spread around the world, so that's a great place to release your games. And there's a trade-off though. Do we want to do it for the speed of the game, or do we need to optimize for the file side so we get the speed of the transfer? So as one goes up, the other goes down, and everything's like that in a trade-off. So if you're getting into yeah, this will work. It's going to predict it. So periodically, maybe a couple times a year, if you're getting heavily into game development, you're going to do this search right here, best game engines, and go through and look at the different blogs, the top 7, and read through, find out the different, find out where those trade-offs are, and figure out what the best one for your particular situation is going to be. Like top 7, top 25. That one doesn't have a number, but yeah, those two don't have a number, but they're plural, so they're definitely going to talk about more than one game engine. And that generalization, and think about the game, each particular game you want to make, and what would be the best engine for it, because you don't want to get pigeonholed into a specific only knowing Unity. Right up here, there's these search results for all these different ones. We were very restricted on time, so we only looked at Unity. Game Maker is great for 2D stuff. It's been popular for a while. Godot is the free open source software, so you can get the source code to the game engine. But that's the Linux user one. Lumberyard is pretty nice, but it's free to use, but it's connected to an AWS account, and your AWS account on those servers aren't going to be free. But once you pay for the server time, the processing on that server in an AWS server farm somewhere, probably Virginia from where we live, then you can use the Lumberyard game engine there, and it's built right on their stuff. But it's just a server. You're paying for the server, so at that point you could just export a web thing from any of a major game engines and look at them. So what I was thinking for wrapping this up is we've spent all our time looking at Unity. So I was going to open one that I have not looked at and kind of go through the process of those first few steps before even jumping into a tutorial or anything. Just opening up a new game engine and seeing if I can find my way around it based off what I know about other ones. So as we look through here, JMonkey's been on my mind for a moment because I really like Java. Java is probably my favorite language to code in, though sometimes I think that's probably just because I've done so much more in Java than any other language. So there's more experience there, and jumping between lots of languages, that one comes back to me quick. And I also thought, for those who have seen Java before, you probably noticed C# is a whole lot like Java. They seem to have a lot in common. C# they first started development about 6 years after Java was created, and Java was cleaning up C++ because it was such a mess. So then 6 years after that, when they made C#, they were able to look at Java and look at all those parts that were good, and then clean it up a little bit more and look at Visual Basic, what Microsoft was doing everything in before that, and take some of the really nice, easy to use parts and efficient parts from Visual Basic and work those into some of the improvements that were found in Java. So I was thinking, if we look at JMonkey here, is that a free one? Let's see. License. Yeah, so very permissive BSD 3-clause license. We want to check those things out, make sure everything's okay to use. JMonkey has a store, a lot like Unity. We can go in here and buy lots of assets or download lots of assets. Lots of different things. What is download? Probably get started. Well, looks like there's a lot of configuration to this one though. Have to configure it to work with NetBeans or whichever IDE you really like. So that'll probably take a while to configure. So let's maybe look at something different. I haven't really looked at that. I was wanting to look at something I hadn't looked at before. Panda 3D is one that was developed by Disney in 2013 or 14. Whenever Disney did the Toontown Adventure game, Panda 3D was the one they made. It uses Python, and it's probably my favorite game engine to work with in Python. RPG Maker. What do these look like? I think this is sort of more of a world creator thing than a full game. Yeah, this one's for making big worlds. What is this? Solar 3D. Let's try it. Look at this. And one thing I found when looking at different engines is try to find some pictures of them as well and make sure that the interface looks good. Where's that one I clicked on first? So I'll do that, like searching for JMonkey. If we just go to images and look at sort of what it looks like configured in there. So here it is working with NetBeans. So we'd have to install NetBeans, and I don't think I have Java on this computer. I might kind of look at pictures and just try to evaluate, recognize some of the things in the images, basically. Hopefully that makes sense. That's usually the first thing I like to look at. So what are some of these others? What's G develop? Free and easy game making app. That sounds nice. So that's event driven system. So it's probably a lot like, try it online. It's probably a lot like Scratch or something like that. So I'll just create a blank one. Sure, let's see what this looks like. So look through here. See properties and objects. Oh, I missed something in the chat room. Sorry. Okay, yeah, that was the same thing I was thinking about JMonkey is in the chat room. The output doesn't look that great, but it uses Java and makes me want to try it. That was the exact same thing I was thinking about it. It's like, hell, I kind of like working in Java. So I just tried a random one here. Looks like they have an online thing. Let's look around, some debugger stuff, preview this game. Actually publish the game, which an online editor makes me think the default release is going to be a web thing. Looks like a hierarchy object over on the right, and properties. Click on an instance in the scene to display property something. And this is like the inspector panel in Unity. And yeah, the first time when you first open one, over the years, I found that it's better to spend a little bit of time clicking around and looking for things you recognize before running to a tutorial. And because you don't want to run to a tutorial every single time, right? You don't want to have to go look up every single step of making the game. So as you look around, look for things that you can recognize in that new engine. So I'm thinking a good place to start is probably add a new object to this game. Add a house to the game. Yep, add that. See tile sets. Yeah, libgdx also uses Java. Was done in the chat room. There are a few of them. Oh, there it is. The Zoom thumbnails were hiding the close button. So have this now. Drag and drop to the scene. Oh, that's nice when there's hints right in there. Okay, so that gets us an object in the scene. If we select it, some editing things to see a position, rotation, Z order. So this is kind of the way I like to do it, even in Unity. There's the layers where we can use layers to say what's in front of or behind. But personally, I find it a little more intuitive to just, like in a 2D game, to use the XY axis to position it, and then use the Z as the coming in or coming out of or heading back into the screen, and get our layers that way. So it looks like this is set up that way. We also have the layers there. Some scaling it. It's under edit objects. Maybe some closing things. So what else can we put besides an object? A delivery truck. Yeah, add that to the game. Close. So maybe we can make a truck run into the car. Wow, that's really small. A great big truck run into a little bitty house. And from what I've seen in other game engines, I'm guessing that big box here is our camera when we preview stuff. Put that down. Go hit preview. I'm thinking that box is showing us what we'll see. Yeah, so we start our truck over here, and now just see if we can figure out how to make that move without looking things up. That's just something I found over the years. Like, give it a try, because if you can't get some simple things working intuitively, you're going to find yourself looking things up over and over and over again. Object groups, objects, instances, layers. Set some things up, settings. I'm just going to right click. Edit behaviors. That's probably what I want. Oh, that's always nice too, when it links directly to a tutorial right there in your thing. Experiment outside, draggable object, top-down movement. Oh, that sounds like what I want. The top-down movement, acceleration. We talked about physics last week. It's much better to move things by an acceleration, because then we can think about things interacting in the world by the force applied, which is how our real world works and what our intuitions are used to. Max speed, angle offset, rotate it, viewport. Let's see what this does. So on the truck. Oh, no. Close that. So a lot of clicking around, y'all kind of know how that works. Hit preview. I don't see any sort of movement or anything. So maybe that's, I don't know if that was applied. Oh, run a preview. Let's see what this looks like. Nope, our truck does not seem to be moving. Oh, wait, default controls. Oh, I'm using the arrow keys. So that was enough. So we can come over here and, oops, backwards was weird, but was able to make something happen very, very quickly just from clicking around. So that might be something to look a little further into. That looks like it's probably not going to make a nice game, but okay, go ahead and leave this. What else we got? Unity, Godot. I think we have to be on AWS. Let's see. It says download, so let's give this a try. Yep, download it for Windows, download installer. And this is a more high-end one. That one looked like one of those basic ones, get the concepts down, maybe practice logic or like Scratch, introduce people to the basic idea of programming logic by moving graphics around. I'm a much bigger fan of that than introducing logic by concatenating strings. The graphics give us that visual representation to help us make sense of things. Yep, install that. Hopefully this won't take too long. But while that's going, sort of a recap of the things we've talked about this semester. So we have covered a lot of things. I'll flip back through the notebook. Started, the first thing we went into was just some basic usage on Unity that starting out. Let's see, and we looked at storytelling because that's sort of our main goal, right? Is we want to use graphics and program as far as the user interacting and controlling those graphics to tell a story. That's what our games are trying to do. We looked at Blender. We went there a couple times to get some different that kind of get started. That stuff takes a lot of practice, so it's hopefully this class worked to point you in different directions. That's 2.120, 248. Oh, upload to GitHub. Remember that's important. This engine that's installing right now, which hopefully isn't going to take very long. I wonder if I stop the screen share if it would go quicker. Probably not, because Zoom's just going to take that much of the bandwidth anyway. But our video games, especially the big fancy ones, that last engine we looked at briefly there, looked like it wasn't too bad. We're in just a couple minutes was able to put 2 images on there and make one of them move with a key press. So very quickly get things together, but a very, very elementary one, just the starting points. So this is the one AWS released as that they are hoping will compete with Unreal. They didn't even say compete with Unity. They say they want to compete with Unreal. So it might be really, really hard to use, but let's take a look at it and see what it is. And you want to try different engines because, yeah, the traditional term for it is pigeonholed. You don't want to get pigeonholed into only knowing Unity, because then if other big advancements happen and Unity starts to fall behind the industry, that's probably a bad example, you'd be stuck having to learn a new one from scratch. So make sure you, as you take the time to learn to practice these skills, practice it in different places and make sure you can get it working and get things working in more than one game engine. That example I just listed is probably a bad example because I don't know if you noticed or not, or saw the articles, but the NASA is going to use Unity to design their new the HUDs and the next generation of helmets as part of the AR. They're doing their HUDs as augmented reality on those helmets. Okay, so, but on most of our big game engines, there's lots and lots and lots of files involved. Usually way more than what the web-based interface on, say, GitHub would let us upload. So we have to use the command prompt on GitHub to upload that many files, and probably the same on most of our repositories. There might be a couple that would let us upload that many files at once, but for the most part, we'd have to use the command prompt instructions to get things to and from repositories because there's just so many files in a typical game. Let's see, storytelling, look at Blender. What else did we look at? 75%, so that's coming along. Then we looked at some math stuff and talk about vectors, things working components. Looked like the vector stuff went very, very well on that math quiz, and that's the important one for game developers. While this is downloading, the other math thing, it didn't go quite so well in the quiz. After I finish grading those, usually if everybody in the class misses the same question, I'll put the points back on there and talk about that. But the thing with probabilities is, one thing that I was noticing seemed to be forgotten a lot is, remember, probabilities are always a fraction. So on like that chart, several people were reading the correct number from the chart, but then forgetting to put that as a fraction over the total. And we ended up with a number that was way bigger than 100% chance. And the big thing is the notation. Because if you have to go look things up about probability, you're probably going to see the standard math notation. So just a recap on that. So probability of some event, we're going to call it A. The chance that it happens, that's somewhere between 0 and 100%, or 0 and 1.0. Probability of A intersecting B, which on the chart, everybody was tracking those numbers down pretty well. On a chart, it makes sense. The intersection is where that row and column match. But the intersection is the technical math symbol you're going to see for and situations. So since we're programmers, every time you see that symbol, just read that as and. Probability of A union with B, again, it's a logical operator, so that's our or situation. And I'll put the complement up here. We can also do, if everything is 100%, we can also take 1 minus the probability of A to get the probability of everything that's not A. So as programmers, that's what we would think of as not. So reading that, one thing I noticed on the quiz with the or situation, the union, is remember to subtract. So like on those charts might have something like the probability of this column or this row, and we would take our two totals as a probability over our total. Oh, looks like that's starting to install now. Over our total, but what you want to remember is that this cell right here where they intersected got counted twice. So we need to subtract back off that because we don't want to count it twice. Again, mostly just the notation thing. Probability of event A given event B. So the given, it means that the one after it definitely occurred. So like if this is A and this is B, when we have that given B situation, it like narrows down our chart. So if we have things where it's all in a chart, we know event B happens, so we can erase everything else on that chart and only worry about that one row. So we have a new total and then we just want that one that happened from that row. So it narrows it down. But the big thing we probably want to do, other than that notation, if we have to look things up, is probably more along the lines of what you would think of a D&D in a D&D game, right? So we set up a random number. So like X, well, we looked at stuff in C#, so integer X is random dot range 0 to 20, and then that's going to represent like a 20-sided rolling a 20-sided die in a D&D game. Usually it's okay to reference D&D in software development classes. Most programmers seem to have at least heard of it, if not be a regularly partake in the game. And then we just need to check something. So maybe if X is exactly equal to 7, then that's a 1 in 7 chance of happening. 1 in 7 chance of happening. What is 1 in 7? It's not a nice even number, but it's definitely less than 100%. 1 divided by 7 is 0.14. So 14.3% chance. Else if X is greater than say 14, well, that could be greater than 14 would be 15, 16, 17, 18, 19. Because we just went 0 to 20, not so 20 is not included, but 5 out of 20 things. So 5 out of 20, or 1 out of 4, or 25% chance. Might fit nice in the sentences we're thinking about that. That's what we're mostly going to do with probabilities. We didn't spend a whole lot of time looking at that directly because yeah, our time was very, very short. But aside from the notation and that stuff, which is just in case you ever have to look it up, in your game itself, think of it like rolling die. How big is the die you're rolling? And are you choosing just one number off of it? So like 5 numbers on that will count as okay, different things like that. And since it usually happens so quickly, I like to add in a frame counter. We saw that a few times, right? We have that frame counter that just increments every time. So add that in as an if condition. So like if frame mod, so we're in at 60 frames a second. So frame mod 120 would mean it's been at least 2 seconds and that 1% chance happens. So that's what we really need from probability as far as programming games. So usually it's going to be either just the probability that it happens, but with every frame of the game, you might want to back off a little bit from the pure probability, because 1 in 7 chance happening. Oh wait, that's not 1 in 7. That's 1 in 20. I thought something looked strange there. 1 in 20 is a 5% chance. I guess we could break it down to 1 in 7. 1 in 7 would be like 3. 3 numbers that it could be. I'll put that back in here. Else if X is greater than or equal to 2 and X is less than or equal to 4. So 2, 3, or 4 gives us 3 numbers. So that's roughly 3 out of 20. 3 out of 20, about 1 out of 7, which was the, whatever I just wrote there, 14.3% chance. But it's happening 60 times a second. So if we take 7 divided by 60, we're going to redo that 9 times, basically every second. So backing it off and adding a little bit of a weight in there can make a difference too. It looks like this finished installing. I'm going to save that. Don't save. Okay, so let's launch this and see what it looks like. So yeah, kind of this is I haven't looked at this one before. This is related to AWS, so this is going to be optimized to run on the web. I already know that just because it's an Amazon thing. Like I said before, you always want to try the engine before looking anything up. Just randomly click around off what you already know and make sure you'll be able to kind of get a sense of whether or not you'll be able to figure stuff out, or if you're going to have to go look up every single step along the way. So this looks kind of familiar. Projects, the engine. Okay, just some data about it. Where is it at? Third-party software. So general data on that one. Oh, that's nice. Add a repository. Probably going to have to look that one up, but being automatically synced to a repository somewhere definitely sounds like a really good thing to have in the software. So that's a plus on there. Create a project, add a project. So that sounds very familiar from the Unity Hub. We create a new project, and I'm guessing the next time we come back there, there's going to be an open a project button. Let's see. Project templates are pre-configured with relevant gems that provide additional functionality and content to the project. Default or minimalistic. Call it new project. So starting point input, texture atlas. So I'm guessing that this starting point input is similar to controls and things. Texture atlas, well, textures go with the materials, so probably some basic rendering things, and an atlas sounds like a map. So I'm guessing there's already a bunch of textures there for us to use, so we don't have to go make our own and stuff. The core engine, editor Python bindings. Well, that sounds like a good sign, because I haven't even bothered to look what language this one types in. So if something is scripted in Python, that's always nice, because Python's very, very easy to use until you have to look for the missing white space. And then it's really, really aggravating. And you start to miss semicolons and curly braces trying to track down where the white space got wrong. It's very easy to notice if there's a curly brace missing or an extra one. There's something to see or not see. If it's your white space is off, that can be a little bit difficult. Landscape canvas, not sure what that is, but it sounds useful. And just kind of look through the things, and looks like it's customizable, so that sounds good. Oh, and create. We'll go ahead and create a default one, see what it says. Visual Studio version. Uh-oh. Does this one have to work with Visual Studio? So I see that as a problem right away, that we only have one choice in IDE. And it's the full Visual Studio. From looking at this, I don't think VS Code would work for us. So that means it wants us to do the full the 15 gigabyte text editor. And something seems off with text editors that are 15 gigabytes. Not that big of a problem, but sort of a binding point. So I'm gonna go look and see if there's another one we can look at real quick. Just try different things. And that's the general process. I'll open Godot. I've used Godot a few times, but I'll go through the process here over 10 minutes. Standard version. Oh, probably should have done C# support, but that's fine. And yeah, try different engines. Just look around at them, see if there's something you maybe don't care for, like the requirement that it only works with Visual Studio. Y'all have probably encountered Visual Studio in classrooms, right? A 15 gigabyte text editor seems odd. That's kind of a lot for writing code, it seems like. But if you've never looked at it, that's $6,000 software. When you're not a student anymore, Visual Studio costs you $6,000. That's the biggest issue I have with it. That's a serious chunk of money, right? Even if you're making really, really, really good money, pay $6,000 for a piece of software is a lot. Oh, you can develop under community, but you can't make money off of it. You can't sell what you develop on community. So community is for developing open source stuff. Yeah, so I'm going to open this other one and look at that, because only having Visual Studio available feels like a breakpoint to me. Yeah, you can develop stuff under community, but if you go to make money off of it, you have to get the paid for enterprise license because you're an enterprise. And that is a lot, unless you're even making really good money. $6,000 is a lot to pay for a piece of software. So that's a big break point for me, that I can't write the C++ code somewhere else. It only seems to run there. So looking at this other one, we get other things out of the way. Close that. It's here. Oh, so I'll just minimize that, get out of the way. So it looks like another little boot up thing. Don't have any current projects, explore official examples. That's probably a good place to start, but I was just going to click on random things because I was only planning on going till about 7:15 or 7:20. So let's see how far we can get in 5 minutes. The interface looks a little bit different, but it's still very similar. Put this in a delete folder, so I remember to delete it. That'll work. Select current folder. Oh, please choose an empty folder. So we'll need to create one. Test. That sounds like a good name. And select this one. Okay. So empty folder. I'll just go with the defaults. Open GL render, see what's there. And as this opens up, some of it looks kind of familiar. I see a tab labeled inspector. So probably safe to assume that does the same thing as the inspector in Unity. Node. We've got over here. So file system. So it looks like File Explorer over here. Or we don't want to search favorites. I'm guessing that might be assets. And try. So create a root node, maybe a 2D scene. Okay, so it changed, picking 2D changed a little bit here. Probably need an object. There's an image here. What happens if I drag that in? Oh, so that looks like it worked just like in Unity. So let me just real quick open up Paint, grab a couple things, and yeah, this is sort of something you'll want to do occasionally. Just open things up and give it a try. So real quick, I'll just grab a pen and draw a house. Oh, at the end of it. There we go. That looks like a house. So file, save that. Delete folder. House. File, a new one. And I'll draw a car. That works. Save that as car. And now if I go back over to Godot, I have the same drag capabilities that I know from Unity. And yeah, before going to a tutorial, give the things you know a try and see how much you can get working. Oh yeah, looks like I can drag those in. Let's get rid of that. And put the house over here. And the car over here. Make the car way smaller than the house. And so it's like dragging images in was no problem. I need to get them to move somehow. As we click on one, offset, some things to expand, some sort of offset, flip it, region, where is it located at, I suppose. Transform data, familiar with those, the position, rotation, scale. That's the things we work with most often because that's moving stuff around our screen, and that's a big part of the game. I guess Z index for layering. Right now it looks like the house is, or the car is in front of the house. Do that. Probably need to adjust this number to make that car move. And hopefully y'all see what's going on here, right? Just opening this up and just sort of randomly clicking around, trying to find things that look familiar. What do we have here? There's stuff for scenes, project settings. Oh, this looks an awful lot like those options we had in for some of those things in Unity. Different ways to control our physics. I don't see a layer option. Oh, rendering layers, or physics layers. So looks like that's where those would be at. Oh, input map. Oh, this looks nice. Things are already set up there. UI accept these. Left is left, device 0, button 14, just D-pad left. I'm not quite sure what it's using there for, but I'm guessing those are, I see down, up, left, and right. So it looks like it's set to the arrows. If I can figure out how to get those in the script. I see a tab that says script. So maybe file, a new script. Okay, so there's an editor there, can create it right there. What about over here? If I go back to, say, this car object. Oh, there's already a script position. So looks like it might be better create it from there. Oh, well, I started out a little bit. Declarative variables here. So looks like we're a subclass of sprite for all our scripts. From studying Unity, we were always a subclass of monotype behavior. So I'm guessing this, from that template, it looks like we're starting from that. I think this is Lua. I think when our keyword is func, it's we're typing in Lua. But I haven't typed in Lua in a while. Var, that looks like JavaScript. Okay, so func ready, called when node enters the scene for the first time. So this is like our start method, apparently, and called every frame. Delta is the elapsed time. So we uncomment this, then this is the equivalent to the update method. Does everybody agree with me just from what's looking on the screen? Any thoughts there? And then we could, I guess the main point, so we're not going to dive in very deep here. Actually, that's 7:19. So this is about when I was wanting to wrap it up. It seems like a good point. So looks like we have different names for what we were doing in start and update, but still kind of the same process. The thing that gets called once, followed up by the thing that gets called every frame. That's how we control our script. Our object has the transform data. So looks like there's a node 2D. The transform relates to the node. So somewhere in our script, there's got to be a way to refer to a node. Do we have predictive text? Oh, I guess I have to comment this, don't I? Okay, so node 2D seems to be a type of object. Test equals new node 2D. Doesn't seem to be throwing an error. Maybe get some starting tries. Lua is not fresh on my mind, so I don't know if I could do much more than create a bunch of errors, just trying around. But the main point there is just looking around and seeing what you can recognize from what you do know in that new situation. So it looks different, but I see a whole lot of things that seem similar to Unity. What if we go to 3D? Oh, wait, we're in a 2D node. It's a little bit different, and that's where you're going to want to take this, because everything we did this semester, we were looking at Unity. But you don't want to get pigeonholed and stuck. Whoops. You don't want to get stuck only knowing one engine. We're trying to look at things in a very generalized sense. So we looked at graphics, talked about those concepts, that be in the right frame of mind and sort of understand what you're doing, and then jump around, look at different engines and try to do some of the things you know from randomly clicking on stuff. And you'll probably figure out pretty quick if you're going to be able to figure out what to do on that engine, or if you're going to end up looking up having to look up every single step along the way. You want to try some of those things and look at different varieties and make sure you can apply these concepts in different situations. But you want to get very familiar with Unity first. We barely scratched the surface of Unity. Did I close all the Unity games? Hopefully it'll just take a second to open back up here, because okay, yeah, it was just open, so I figured it wouldn't take very long, because we barely scratched the surface. We saw how to make some new objects, add components, different little the functionality in the objects, start moving things around based off the transforms and all that, adjust our camera to look at things, got a sense of debugging it, but we've barely scratched the surface. Game development is huge. Hopefully this course helped y'all along the way about putting together that right frame of mind and how to approach things, and got a little bit more experience just doing it, because that's what it really comes down to, is experience. It takes a lot of time. It takes way more than 8 weeks to look at every button in Unity in one game engine, as you have definitely noticed as we wrap up things here. So hopefully that got you moving down that pathway. Let's see, it's 7:23. So there's an hour and a half left on our scheduled time. And well, this is kind of wrapping up the semester. So during this block that you had scheduled for class is a great time to finish things up if you still have some stuff to do. The semester ends tomorrow at 11:59 p.m. So no late submissions. That's the final deadline. Everything shuts down. Everything will automatically close and lock at 11:59 p.m. tomorrow. And then on Wednesday morning, I'll finish up any grading that's left and submit grades. And I wake up early, so I will probably have the grades submitted. I usually have the grades submitted by like 7 o'clock in the morning on Wednesday, the day after, on that final day. So please spend the rest of our time productively. As always, I will be sitting here until our scheduled time. Ivy Learn messages and text messages make noise on my phone, and the ability to ask me a question does not stop at 8:50 tonight. Keep my contact information. You are always welcome to ask me questions. I still get questions from students who graduated a couple years ago that have moved into working careers and develop software and much trickier pieces of software than we see in classrooms. So every once in a while, I still get those questions. Keep my contact information around. I'm always happy to help if I'm able to. So otherwise, hopefully that helped get you all off on a good, y'all have gotten started on a good pathway, a good footing to explore game development and make your own games. And I'm really looking forward to grading your final projects. I know there's some interesting things there. Otherwise, does anybody have any questions? Oh, yeah, thing about a few zero grades. I fell behind on grading. There's 30 students in the SDEV 120 class, and they have lots and lots of final projects, and all the late work is coming in. So yeah, all of that's been coming in, and then with some other things going on, I've fallen behind on grading. But yes, I am aware of that, and I will get the grading done very soon. Everything will be graded by tomorrow evening. Before I go to bed tomorrow evening. Yeah, before I go to bed tomorrow evening around 10 o'clock, I will, hopefully by 10 o'clock, if it gets pushed back to 2 or 3 in the morning, everything will be graded before I go to sleep tomorrow evening. So if you've turned it in, I'm aware of it. I've just gotten overwhelmed. Any other questions? Make sure I caught all those. Oh, whoops. So I guess that wraps up our class. Y'all have a great summer. Yeah, if you have any questions, let me know. I'm gonna be sitting here till 8:50, but keep my contact information. You are free to ask me questions indefinitely. I'm always happy to help. Y'all have a good one.